Hi friends, in the last video we discussed about the solid state. In that we see the properties of solid, then types of solid, that is two types of solids are there, crystalline solid and amorphous solid. In that we discuss about the two important properties, that is anisotropy and isotropy. Then we also discuss about the two terms, that is polymorphism and isomorphism. Then we discuss about the classification of crystalline solid. In that we classified the crystalline solid into covalent solid, covalent network solid, ionic solid, molecular solid and metallic solid. Now today we are going to discuss about the structure of crystal. What is crystal structure? So crystal structure, it is the three-dimensional arrangement of particles. How particles are arranged in three dimension, it describes the crystal structure. So to understand the crystal structure, we use two terms. These two terms are the lattice and basis. Lattice and basis. What is lattice? Lattice is the geometrical three-dimensional arrangement of points. Three-dimensional arrangement of points. Suppose actually it is two-dimensional arrangement of point, but such a three-dimensional arrangement of points is nothing but lattice. What is basis? This basis, it represents actual particle. Now you know, in case of solid, so in last video we see the different types of crystalline solid, and in that we discuss about the particles. So these actual particles, they may be ions, they may be atoms, they may be molecules, or they may be a metal cation which is surrounded by delocalized electron. So these actual particles is nothing but basis. Now when we put this basis on this point, when we put this basis or the actual particle on this point, then we get a crystal. So we can say that this crystal structure, is nothing but lattice plus basis. So lattice plus basis, it gives us the information about the crystal structure. I think you got it. Now we understand crystal structure by using the two terms, that is lattice and basis. Lattice is the three-dimensional arrangement of points. This three-dimensional arrangement of points, it is also called as space lattice. Now friends, let us consider a lattice. This is when lattice is there. Actually, it is two-dimensional arrangement. We convert it into three dimension by using our three axes. Suppose we consider this point. So from this point, I plot x-axis on this direction. Now this is my y-axis and it is z-axis. Now imagine it into three dimension. Now I join the points on each axis. What I am going to do? I am going to join the points on each axis. So on y-axis, these 3 points are there. If we consider this point on y-axis, so these 3 points are there. I join them. Then if we consider this point, then I join these points on y-axis. Similarly, yes. So these are the points on y-axis. Now I join the points on z-axis. So this is z-axis. So these points are there on z-axis. Then again these 3 they already joined. Next one. Yes. And finally I join the points on z-axis also. Wow. I got one geometrical shape. So this one geometrical shape, we called it as crystal system. This is a crystal system. So these points, if we consider these points as basis or actual particles, then we get a crystal. So it is crystal lattice or space lattice. Now my dear friends, look more carefully. The whole or entire geometrical shape, it is made up of same but small geometrical shape. It is made up of small geometrical shape, and this small geometrical shape, suppose I consider this shape. This part or this smallest unit is repeated. So this smallest unit is here, similar smallest unit is here, similar smallest unit is here, similar smallest unit is here. Whatever whole entire crystal, entire geometrical shape is there, the same shape have this smallest unit. And friends, this smallest unit which get repeated to form this crystal, to form this geometrical shape, this smallest unit, we call it as unit cell. So unit cell, it is the smallest repeating unit in crystal structure. And my dear friends, by mathematical analysis, it has found that there are 7 types of arrangement of points can be possible. So these 7 types of arrangements are possible. That 7 types of arrangement of points, we call this arrangement as crystal system. So 7 type of geometrical shapes are possible, which we call as crystal system. And in this crystal system, we can arrange particle in 14 different ways. And these 14 different ways, we call them as Bravais lattices. So to understand this 7 crystal system and the various 14 different ways of arrangement of particles within this crystal system, that is Bravais lattices. So to understand this, let us discuss the unit cell first. So we move towards the smallest repeating unit in this crystal system, that is our unit cell. So as already told, that unit cell, it is the smallest repeating unit of crystalline solid, and by stacking the unit cell together, we can generate crystal. So for example, this is my unit cell, and by stacking so many unit cell together, we can form a crystal. In crystal, each unit cell, it shares its faces. So these are the faces. Then each unit cell, it shares edges. So these are the edges which are going to be shared, and corners also. So these are the corners of unit cell. So in crystal, each unit cell, it share its faces, its edges and corners with neighboring unit cell. So to understand our 7 crystal system and the 14 Bravais lattices, let us discuss about the parameters of unit cell. So unit cell parameter. Let's have a smallest part. Let's take one unit cell. So we consider this point, axis of this point. So it is our x-axis, y-axis and the z-axis. Now imagine this unit cell in 3 dimension. For 3 dimension imagination, I've drawn the axis of that unit cell. Suppose the dimensions of unit cell along each axis is, so we consider here axis, x-axis, y-axis and z-axis. Suppose along x-axis, so this dimension is a. So along x-axis the dimension is a. Along y-axis the dimension or the distance between these two particles is b, and along z-axis it is c. So this is about dimensions. Now let us denote the angles. So it is dimensions, we called it as edge length. Then it is dimensions, then we have to focus on angles. Now in between these two dimensions, that is in between AB, angle between AB, we denote this angle as gamma. So this angle between A and B, it is gamma 1. The angle between B and C, this angle is alpha. This angle is alpha 1, and the angle between A and C, it is beta. So how to remember these angles? The angle between, let us consider alpha means A, beta means B and gamma means C. So we have to denote the angle between AB. So AB, which is not there, C. So C means gamma. BC, so A is not there. So A represents alpha. So here AC, B is not there. So the angle is beta. So these are the unit cell parameters. That is, these are dimensions, that is edge length. Along x-axis it is A, y-axis it is B, z-axis it is C. The angle between A and B is gamma. The angle between A and C is beta. The angle between B and C is alpha. So why we have to determine these parameters of unit cell? So by using these parameters, we have to understand 7 types of crystal system. So this is one type of crystal system. We have to learn about such 7 types of crystal system. To determine this 7 crystal system and Travis lattices, we have to go further the types of unit cell. That is, in this arrangement of particles, how particles are arranged in the unit cell. And by using these two terms, that is parameter of unit cell and type of unit cell, we are going to find out, we are going to know the 7 crystal systems and the 14 Bravis lattices. Now let us move towards the types of unit cell. Friends, these unit cells, they are divided into four types. So the first type is primitive, or it is also called as simple unit cell. Then second type of unit cell is body centered unit cell. Body centered unit cell. Third one is face centered unit cell. And the last one is, it is base centered. Base centered unit cell. So unit cell, it is divided into four types. That is primitive unit cell, body centered unit cell, face centered unit cell, and base centered unit cell. Let us discuss one by one. So first one is primitive or simple one. In this unit cell, our constituent particles, suppose it is one type of unit cell, one unit cell or one geometrical unit cell. When this unit cell, we call it as primitive or simple. So in this case, the constituent particles are present at corners only. So this is unit cell. Suppose it is a constituent particle. If such a constituent particle is present on the corner, so for this unit cell, each unit cell, it possesses 8 corners. So this is one corner, particle is present at the corners only. So this corner, similarly at this corner, this corner, this corner. So all 8 corners, they are occupied by constituent particles. So this arrangement is called as primitive or simple. So in primitive or simple, I repeat, in primitive or simple unit cell, constituent particles are present at its corners. Got it? Then second, body centered unit cell. In body centered unit cell, suppose for this unit cell, if we join these points, so this point, I join it to this point, then this point I join it here to this point. Similarly, these 2 points and these 2 points, when I connected these points, then I got a center, that is the center of this body, center of this unit cell. And if the particle is present at the center, if the particle is present at the center as well as at the corners also, then it is called as base centered unit cell. So it is called as body centered unit cell. So in case of body centered unit cell, one constituent particle is present at the center of its body in addition to the corner particles. Clear? The third one, that is face center. So for this unit cell, it is its face. If I join these 2 points, then these 2 points, I got one center here. This center is called as face center. So in case of face centered unit cell, constituent particles are present at the center of each of the face. Suppose this is a one phase, then particle is present here in this space, in this center of this space. Similarly, particle is also here, one particle is here, one particle is here. So whatever, so this unit cell, it possesses 6 faces. So all this center of all the faces, the constituent particle is there. So for face centered unit cell, I repeat, constituent particles are present at the center of each faces in addition to corner particles. And the last one, that is base centered unit cell. In base centered unit cell, constituent particles are present at the center. Constituent particles are present at the center of any two. Means if one particle is present at the center of this space, then another particle is present its opposite face. Remember, only opposite faces. Particles are present, constituent particles are present, only opposite spaces. But remember, in addition to the corner particles. So these are the 4 types of unit cell depending upon the arrangement of particles. My dear friend, by using these 2 concepts, that is types of unit cell, simple, body centered, face centered and base centered, and parameters of unit cell, we are going to discuss about the various crystal system, that is 7 crystal system and 14 Bravis lattices.